We are doing A16, and it's a new concept, which actually is not new to you, and we are breaking down square roots into simplest form. So you're going to take something like the square root of 24, and you're going to break it down to have a perfect square taken out and anything left over. Now, I know I can just type the square root of 24 on my calculator, and if I just type in the square root of 24, I end up with this decimal answer. Now, I know that some of your calculators give you the exact answers. However, it is going to be a problem because you're going to have to show the work. So we are looking for this type of answer, not a decimal that you've rounded. Right, so the definition of a square root, what times itself gives you a number. So when we ask for a square root, it says a squared equals b, then a is the square root of b. All right, well, let's sort of make some sense of this. If 5, what's 5 squared? 25. And what is the square root of 25? Okay, so that's what we're saying. If a squared equals b, so 5 squared is 25, then a is a square root of b. That 5 is the square root of 25. That's all they're saying. Now, the radical symbol looks like this. It's not a longhand division. It has a little crook here. And the expression under the radical is called the radicand. Now, we're only focusing on square root, so it's understood that there's a little 2 there. But we don't have to show that because when you see this, we understand it's a square root. However, if it's a cube root, you put a little 3 there. All right, now, whenever you square something, you always get a positive outcome, right? Like 4 squared is 16, but what's negative 4 squared? It's also 16 because this is 4 times 4. This is negative 4 times negative 4, and the negatives cancel. So when I say what's the square root of 16, we actually get 2 outcomes, a positive 4 and a negative 4. Because when I say what is the square root of 16, most of us would say 4. Because 4 times 4 is 16. But what else times itself is 16? Negative 4 times negative 4. So actually, when we get into this later and we're solving, every time we solve, a square root will have 2 outcomes, a positive or negative. Now, today we're only focusing on the positive or the principal root. All right. The expression square root of 16, I just said it, means the square root of 16. That's all it's saying. And we are looking for the positive square root of 16. All right. Now, the expression negative square root of 16 means the opposite square root of 16. So I can have a negative sign on the outside. I just can't take the square root of a negative. Now, if you go through this, it says to simplify radical expressions in simplest radical form, no more decimals, we need to use the product property of square roots. Okay, so what's this property? Now, a and b both have to be positive or greater than or equal to 0. And then the rule is this. If I have the square root of a times b, that is going to equal the square root of a times the square root of b. Again, all of this is Algebra 1, so you've all done this. It's just how much do you remember and how much of it were you told just to put in the calculator, because we're not just putting it in the calculator this year. So if I have multiplication, a times b, underneath one root, then I can break it up to the square root of a times the square root of b. So what's our big goal? Our big goal is to keep exact answers. So keep exact answers, meaning no rounding. No rounding decimals. So I'll say it again. We want to keep exact answers. We're not rounding decimals. So what are we looking for? Find the biggest perfect square factor. Now we have to talk about what that means. We want to find the biggest perfect square factor. So first of all, what's a perfect square? Can you give me an example? Some of you didn't want my little times tables, but there's a reason I gave it to you. 16 is a perfect square. Why? 4 times 4 is 16. Give me another perfect square. 64. 8 times 8. You said 25, which is 5 times 5. What numbers are we listing off of our times table? Yeah, we're listing all these diagonals, right? 1's a perfect square, 4, 9, 16. These numbers are your perfect squares. Yeah, so we have the whole way down. Now, most of us are pretty good. We recognize 144 as, we recognize 12 times 12 is 144. But once you get past the 12 times 12 times table from when you were little, these other numbers that we're not as familiar with. Now, obviously, there's more perfect squares past 400. But this is to help you because we want to know, out of all these numbers, do any of them divide into? So that's the other term. Perfect square is a number times itself gives us a perfect square, something we can take the square root of and get a whole number. A factor is a number that divides into something. 2, what are the factors of 6? 2 times 3. So our goal is to find the biggest perfect square that we can divide into the number, and that's why I gave you guys this list, because then we can focus on these numbers. Okay, so flip your paper over. Oh, does everyone have all this?
Yes, ma'am.
Are we good?
Yes,
okay. If you don't have it, we can do that later. Now we're starting off with the square root of 81. And notice the direction. Simplify, express your answer in simplest radical form. You must show work. So let me get in here a little bit tighter on this. The square root of 81. Well, the first thing I'm going to do is, if I recognize it, I'm done. It's 9. If I don't recognize it, I'm going to look at my perfect square list, and 81 is on it. So the square root of 81 is 9. Now, how do I know if I have a perfect square? If I type it in my calculator. Square root key, second, and then right here is your square root key. Square root of 81. If I get a whole number, that's a perfect square. Now, if I try to take the square root of something like 82, you can see it's not a perfect square. So anything that's not a perfect square is going to give me this irrational decimal. It goes on forever. Now, is 20 a perfect square? We agree that it's not because, 1, if I put the square root of 20 in my calculator, I get this ongoing. So I can use my calculator to aid me. I cannot use my calculator to do all the work. So square root of 20 is not a perfect square. We see that. Okay, next, I could also look and see that it's not on my list. Now think about it. 20 is between 16 and 25. So if I just said the square root of 20, I know it's between 4 and 5. And it was, wasn't it? It's 4.47. Okay, now I need to think about numbers that multiply to 20. Like 2 times 5 is 20, right? I'm sorry, 2 times what? 2 times 10 is 20. What else gives me 20? 4 times 5. Anything else give me 20? 20 times 1, right? Okay. Out of those numbers we listed, 2 and 10, 4 and 5, 1 and 20, which number has a perfect square or is a perfect square? That's what I want. So I don't need any of these other factors. I actually probably wouldn't go over those. I would think about the number 20 and think about my list of perfect squares. Okay, 20, that's too big. 16 does not divide into 20. 9 does not divide into 20, but 4 does. So I'm focused on just these numbers, and I'm going to use that rule. Remember that rule said the square root of AB is equal to the square root of A times the square root of B? So instead of writing square root of 20, I'm going to write it as 4 times 5. Now, here's the big deal. I'm asking you to write your perfect square first because that's our focus. And if I have the square root of 4 times 5, I can break it up and make it the square root of 4 times the square root of 5. The 4 is like my A, the 5 is like my B. So as long as it's underneath the square root sign, I can break it up. And the reason I did that was I found the biggest perfect square. What is the square root of 4? So I would write this as 2 times the square root of 5. 4 is a perfect square. That's why we wanted it, so we can take the square root. Is 5 a perfect square? No, so I'm stuck with it. Now, how do I know I did the best I can? 5 doesn't break down. It doesn't have any perfect square factors, so I'm done. Now, I wrote this as 2 times the square root of 5. Guys, that's the same as just writing 2 square roots of 5. So you can say 2 times the square root of 5, or you can simply say 2 square roots of 5. So this square root of 20, it's almost like reducing a fraction. What root can we break out and then take the root of it? Now, if I type in 2 square roots of 5 in my calculator, remember we got that 4.47? 2 square root of 5, oops, I did the wrong key, 2 square root of 5 will give me that equivalent answer, but it's a simplified form. Okay. All right, let's jump over to the square root of 18. Is 18 a perfect square? No, it's not on my list. Agreed? It's between 16 and 25. So the square root of 18 would be between 4 and 5, but I want the exact answer. So think about what multiplies to get 18. 2 and 9. Now what else gives me 18? 3 and 6, but I don't care about 3 and 6 because it's not a perfect square. So I'm really focusing on these numbers. All right, now I'm going to rewrite this as 9. I know you said 2 and 9, but I'm going to write it as 9 times 2. The reason I put my perfect square first is a lot of kids flip things. So if I put my perfect square first, I focus on it. So square root of 9 times square root of 2. What is the square root of 9? 3. So it's 3 times the square root of 2, or 3 square root of 2. Now, at this point, you could start skipping this first step, and you could go right to here. I'm going to keep showing this because I want you to think about why I'm allowed to do it. Okay, is 72 a perfect square? I agree. It's not a perfect square. It's between 64 and 81. Do we agree?
Yeah.
So that would be between 8 and 9, because the square root of 64 is 8, square root of 81 is 9. So if I type this in my calculator, square root of 72, I get 8.48. Now, I want the biggest perfect square that divides into 72. So here's the deal. If I say I want the biggest perfect square, you have several things you could do. Some people teach that you do the prime factorization and then you pull the square term. I'm just saying, like, let's look at a list of perfect squares. Now, if I start small, does 4 divide into 72? We'll take your calculator and take 72 divided by 4. So there's a perfect square. Does 9 go into 72? Nope, there's another perfect square. So this is not the biggest perfect square because 9 works, right? You got to keep trying, guys. So then I would take 72 and divide it by 16. It does not divide evenly. See how I get that decimal answer?
So it's 9.
Well, nope, keep going. Does 72 divide by 25? No. Does it divide by 36? Say yeah. So what's the biggest perfect square that goes into 72?
36.
Okay. So there's several things we could do here. First, I'm going to remind you that we found that 4 times 18 was 72. And 9 times 8 was 72, but then we kept going and found 36 times 2. I don't need to write all that, but I'm trying to show you, you have to find the biggest perfect square. Now, there's other factors of 72 also, right? I don't want them because I want to deal with these. Like 3 goes into 72 24 times. They're not perfect squares. So for now, I'm going to say we got it. It's 36 times 2, square root of 36 times square root of 2. What is the square root of 36? So it'd be 6, keep the square root of 2. All right, now I know I'm dragging this on, but let's talk about this. There could be a lot of wrong answers because some of you would have used 4 and 18. You wouldn't be completely wrong, but you would not have broken it down the whole way. So if I'm telling you to find the biggest perfect square, I would start big. So if I say, look at 72, find me the biggest perfect square, well, we already know that 81 is too big, 64 is more than half. I normally cut it in half and start with any perfect squares under that. 36 works. So we could start here and exhaust all possibilities because after I hit 36, 49 was more than half of it. So I normally cut my number in half and look for any perfect squares for that number or less. So that's one way I could find the biggest perfect square. Now, there's another way, and some people get this. Let's say off to the side you took this and you thought it was 4 and 18. 4 is a perfect square. Now, are there any perfect square factors of 18? Yeah, 9 times what? If you guys remember doing your factor trees, remember you would do 72 and you'd have 4 times 18? You found this perfect square of 4. You found this perfect square of 9. What's 4 times 9? 4 times 9 is 36 times 2. So some people understand these factor trees where they find a perfect square, and then if there's a perfect square left in here, they break it down. And if you put your perfect squares together, you get a bigger one. So I think a lot of you are just going to like to try your numbers, but you can use your factor trees. All right, let's go over to number 5. So is 75 a perfect square? No, it's not. So how do I know it's not a perfect square? It's either not on my list, right? Or I typed it in the calculator and I got this repeating decimal. So is there a perfect square that we know that goes into 75? Some of you already know it. It's what? 25. If not, take your 75 and divide it by 2. Now, oh my, 75 divided by 2. 37.5 is my cutoff. So basically, I'm going to my perfect square list saying, okay, half of 72 is 32.5. So 25 is the first number I would try. And then I would try anything else, but 25 is going to work. So this is going to be the square root of 25 times 3. So I'm using my calculator as an aid, but I'm not just doing everything in it. And then I'm going to show my breakdown. And the square root of 25 is 5. Keep the square root of 3. So the big reason I'm asking you to put the perfect square first is that's my focus. And I get a lot of people that do it wrong. I get a lot of people who they write square root of 3, square root of 25, and they tell me it's 3 square root of 5. Well, did you take the square root of 3? Where's its square root sign? And the square root of 25 is not the square root of 5. The square root of 25 should just be what? 5. So I think people that do this are just going through the motion, that lose the square root sign. So please put it in that order. It will help you. All right, 96. Is that a perfect square?
No.
Okay. How did you know it's not? Not on your list? Okay. Now, if it's beyond my list, I would just have to try it in the calculator. So what's half of 96? I'm just cutting in half because dividing by 2 is, that's the smallest thing I can divide by. 48. Okay, is 48 a perfect square? Do you understand that I'm using 48 as my cutoff? So I'm going to try perfect squares like 36, 25, 16, 9, and 4. So this is where the work comes in. I cut my number in half, and now I'm going to see, does 96 divide evenly by 36? No. Does it divide evenly by 25? No, right? 25, 50, okay. Does 96 divide evenly by 16? There it is. But watch this. 96 also divides evenly by 4. So if you used 4, you have to keep going and check. So you can check from the small numbers to the big numbers. I don't care. But if you know that 4 goes into 96, you need to make sure you've tried everything else because 16 works. All right. So instead of having a 96, we're writing it as 16 times what? 8. No, it's not 16 times 8. No, 96 divided by 16 is 6.
6.
Yeah, because it wasn't 4 because I knew it wasn't a perfect square.
Wait, so what do you do?
Okay.
96 divided by
16. Now I'm writing the wrong number again. So we cut 96 in half, right? And that was 48. So I started any numbers under 48 that were perfect squares we tested, and we found 16 divided evenly 6 times. Okay, so what's the square root of 16 times the square root of 6? 4 square root of 6. Now, let's just talk about this. If you would have picked to use 4 and 24, you would have the answer, and you don't have to write this, I'm just showing this. But I do want you to pay attention. The square root of 4 is 2, agreed? So if you put this answer as yours, you would get some credit on paper, but like on Delta Math, you'd get no credit because it's not simplified completely, because 24 has another factor that's a perfect square, which is 4. So then you'd have to break this down again, and you see that can be a little bit tedious. So by finding the biggest perfect square to start, I'm not going to miss it. I'm not going to have to do this 2 times 2 times the square root of 6. And I finally get the same answer, but it was a lot more work. All right, 125 seems like a big number. Do you agree?
Yeah.
Is it a perfect square? Not on my list. Anyone think of anything that goes into 125? 25. Okay, so if we can think of that without doing a lot of extra, I'm fine with that. Now, how do you know you got the biggest perfect square? All right, so the way I would know that you have the biggest perfect square is I would cut 125 in half, and then I'd be starting by taking 125 and trying all of these numbers. And I'm going to find that only 25 works. That's one way. Here's the other way. 25 is a perfect square. 5, are there any perfect squares that divide into 5? So then I'm done. But over here, I picked 4 and 24 had another perfect square hidden in it. So I can look for those factors. So square root 25 times square root 5. What is the square root of 25? 5. So I write it as 5 times or 5 square root of 5. Now, there's going to be some Delta math problems where you have to show this, where it's called guided. So you have to put in the number you're using and then show what happens. All right, 289 is a big number. So first thing I'm going to look, is 289 a perfect square?
Yes.
It is. Now, if I don't have a list that goes that high, I would just type it in my calculator. Otherwise, I'm doing a lot of extra work. Square root of 289, and if I get a nice whole number, it's a perfect square. So I did not have to break that down at all. Agreed?
Yes.
All right, 27, that's not a big number. Is 27 a perfect square? Nope, try it in your calculator. You're going to get that ongoing decimal. So I need you to look at your perfect squares. What's half of 27? Yeah, it's going to be 13.5. So why did I cut it in half? I don't have to worry about any perfect squares bigger than that 13.5. Does 9 go into 27?
Yes.
How many times? 3. Okay, then that's our biggest perfect square because 3 doesn't break down with any perfect squares. So square root 9, square root 3. Now what is the square root of 9? Just a 3. Notice my square root sign's gone. But we got to keep the square root of 3. Is this making a little bit of sense?
A little bit.
We just have to practice it. Okay, how about number 10? 500 is a big number. Is it a perfect square?
No.
It's not even on my list, so how did you say no so quickly? So I'm going to put it in the calculator and see if the square root of 500 gives me a nice whole number. Okay, so I agree with you guys. It's not. It's like 22 point something. So I need to think about a perfect square that goes into 20 or to 500. 100. Now, does 25 go into 500? Yes.
Yeah.
But 100 is a bigger perfect square, isn't it?
Yeah.
Okay. So 100 times what? So I'm focusing on the square root of 100 because that is 10, and that extra square root of 5 is coming down for the answer. All right, I'm going to give you a minute or two, and I want you to try the next 2 problems. Now, again, I don't care that 6 goes into 12 because 6 isn't a perfect square. I don't care that 3 goes into 12 or 2. What am I looking for? What's a perfect square that goes into 12?
4.
I'm only focused. Okay, so 4 times 3. So write that down and see what you should have. So you have the square root of 4 times 3. And then I'm going to break this down. I like to put the perfect square first. The square root of 4 is 2. Keep the square root of 3. All right, let's try number 12. Is 32 a perfect square? That's the first thing because I don't want to make more work. Okay, it's not. So go ahead and find the biggest perfect square. Two theories of finding the biggest perfect square. Well, several theories. You could do a prime factorization. You could start finding numbers. You could just start jumping in. Oh, 4 goes into 32 8 times. 9 doesn't, but 16 does. 25 is too big. Or cut it in half. Half of 32 is 16, and boom. That's it. So did you guys write it as 16 times 2? And I'm going to say this again. If you are comfortable skipping the first step, you could go right to here. I just want you to understand where the 16 times 2 came from. We're just rewriting 32. And because of that rule, remember that rule, square root of AB equals square root of A times square root of B? I'm basically using this as my A times B, breaking it up. Final answer, 4 square root of 2.